Hello students, how are you? As we are socially isolated due to COVID-19 disease, that's why we need to study from our home, and also we have to stay safe. And as exam is in next month, so we have to prepare for the examination, for the final examination and term examination as well. Now today we'll study about the compaction of soil, that is final chapter of module 2. Today we will learn about the compaction of soil. At first we have to know what is the compaction of soil, what is the use of this compaction of soil in soil mechanics, in civil engineering, what are the factors affecting the compaction of soil, and what are the tests we will perform in the laboratory to determine the compaction of soil. So at first, in definition of compaction of soil, we will say compaction of soil is a mechanical process by which the soil particles are packed more closely together by reducing the air void and consequently increase the dry density. So basically in compaction, what we will do, we will apply the external force to the soil sample, and consequence of that external force, air void will be extracted out from the soil sample, and so that the dry density of the soil sample will increase. So when the dry density will increase, when the overall density of the soil sample will increase, then obviously the dry density of that soil sample will also increase. Now we can easily understand this compaction by this from the slide, where we can see there is a soil sample, three-phase soil sample, which contain air, water and sand, air, water and soil. So the volume of that whole soil sample is V1 and weight is W1. Thereby the unit weight of that soil sample is W1 by V1. Now when we apply the external force or any external mechanical energy to that soil sample, the air get extracted from the soil sample, and so that the volume of that soil sample get decrease, and it has become like V2. Now as we apply the mechanical energy, the air of the soil sample get extract from that soil sample. So basically before and after the applying the external force, the weight of the soil sample remains same, because only the air get extract from the soil sample during the applying the mechanical energy. So so we can see before and on right hand side we can see that gamma 1 is the initial density or initial unit weight of the soil sample, that is W1 by V1, and gamma 2 is the final density of the soil sample or unit weight of the soil sample, that is W1 by V2. So here the V1 is the greater than the V2. So obviously gamma 2 will be greater than the gamma 1, and that means after applying the mechanical energy, after applying the external compaction force, the volume of the soil decrease, and thereby the density or unit weight of that soil sample get increased. Now coming to the requirement of compaction, so we have several requirements. Here are four requirements: to increase soil strength, to improve the stability of soil, to reduce soil permeability, and finally to reduce erosion damage. As we know, when we compact any soil, the density of that soil increase, and thereby the shear strength of soil get also increase. When the density of any soil get increase, it reduce the permeability of soil, it improves the stability of soil, and it will also have a huge, immense effect on the erosion damage. Erosion damage also can be controlled by compaction of soil. Now coming to the next point, there is factor affecting the compaction. Now there are several factors which affect the compaction of soil. Number 1 is water content. Number 2, compacting effort, that is amount of compaction. Number 3 is type of soil. Number 4 is method of compaction. I'm coming to the factors one by one. First, I will go through water content. Water content have an immense effect on the compaction of the soil. Dry soil shows the resistivity towards the compaction of the soil. Now, when we increase the amount of the soil will get lubricated and the workability of soil get increased, and thereby it packed closely. Now, from top left hand side figure, from this figure we can see with the increase of the water content, dry density get increased. But this increment is limited up to a certain limit, that after that optimum moisture content, if we increase the water content, the dry density get decreased. We can see from this graph. So corresponding to optimum moisture content, the density is called the maximum dry density. So if we increase the water content from this optimum point, beyond this optimum point, the dry density get decrease. Now we can also observe this from right hand side top figure, that if we add the water in dry soil, it closely packed and it increase the density of soil. Now from the equation gamma d, that is the dry density, we need to find out the dry density corresponding to different water content while we perform the test. Now while we perform the test in our laboratory, we'll use this formula to find out this dry density. The dry density is generated by gamma d, and gamma d is equal to G gamma W divided by 1 plus E. E is the void ratio, gamma W is the unit weight of water, and G is the specific gravity of the soil. So if you know this parameter of any soil, we can easily find out the dry density of that soil. Now coming to the next parameter, that is compactive effort. Now this is the amount of compaction we applied in the soil. As we know, if we applied a higher amount of compaction energy, the dry density will increase. Now from this figure we can from left hand side figure we can see that higher compaction effort, the top graph of left hand side figure, it shows the higher compaction effort, and a lower curve shows the low compaction effort. Now we can easily observe that with the higher compactive effort we can easily get the high density, and with the low compactive effort we get the low density compared to the high compactive effort. Now from right hand side graph we can see with the different compaction effort, like if we change the number of blows, then corresponding to the different number of blows we can get the different density. So we could understand this factor, that amount of compaction have an immense effect on the maximum dry density of the soil. Now coming to a very important question, that is what is the difference between compaction and consolidation. Now we know what is compaction. In case of compaction, a dynamic load is applied, an external dynamic load is applied on the soil sample, and in case of compaction a static load is applied on the soil sample. So in case of consolidation, actually consolidation is a gradual process of reduction of volume under saturated static load, whereas compaction is a rapid process of reduction of volume by mechanical means such as roller, tamping, vibration, etc. Consolidation causes a reduction of volume due to expulsion of water, only water, from the saturated soil sample. And compaction is a process where volume get reduced due to the expulsion of air from the soil sample without altering the water content. So here is the big difference. In consolidation, water get expelled out from the soil sample, and in case of compaction, air get expelled out from the soil sample. In case for the consolidation, more or less it is very much important that soil should be saturated, but this condition is not applied for the compaction. Compaction is possible in case of saturated soil or partially saturated soil that doesn't have any effect on the compaction of the soil. Coming to another important question, that is what are the different methods of compaction used in the field? We generally do the compaction test in the laboratory to represent a field condition. Now, to represent this, to make the field condition as like the laboratory condition, or the laboratory to achieve the laboratory density in the field, we generally use different method of compaction. Like we can use tempers. It may be hand tempers or it may be mechanical tempers. By using these tempers, we generally compact the field. Now we can use different types of roller. Here we can see in this figure we have smooth steel drum roller, we have pneumatic tired rollers, we have sheep foot rollers, and we also have this grid rollers. So these different rollers have different role in the field to compact that field in a particular density, to achieve the particular density or under the different moisture content. Now this roller are widely used in the field to achieve a particular dry density or particular bulk density. Now vibrating plates roller, that is vibratory rollers, are also have an immense use in the field to achieve the desired density in the field. Vibratory compactors can compact the granular soils to a very high maximum dry density. So this has an immense effect on the field. That is we called vibratory roller, vibratory roller. Now tempers also have an effect, also an effective effective way of compacting the field soil. Now we generally use this temper in the field to achieve the what I told earlier, that is our desired density. Now coming to the standard Proctor test. This test has been conducted in the laboratory to assess the amount of compaction and the amount of water in the field. Now in the year 1933, there was a scientist called Proctor has invented this standard Proctor test, and he suggested this standard Proctor mold of height 127.3 mm, diameter 100 mm, and there is a base plate which we can see in our slide, that there is a base plate and the mold having 100 mm diameter and 127.3 mm height. There is a collar of 60 mm height and same diameter, that is internal diameter is 100 mm. There is another part called rammer. The height, the weight of the rammer is 2.6 kg, and the height of fall of this rammer is 310 mm, and the die of the plunger of this rammer is 50 mm. Now coming to the, so this is the description of the standard Proctor test apparatus. Now coming to the procedure of the test. Now at the very beginning of the test, we will take 2.5 kg sun-dry sample, and that should be 4.75 mm passing. And in the second step, we'll mix this soil with water so that the moisture content becomes 6 to 8%. Now this moist soil is placed in the mold in 3 layers, and in each layer we will provide 25 numbers of blows by using this 2.6 kg weight rammer. The blows should be evenly distributed on the surface of the soil, and the soil surface is scratched with the spatula before next layer is placed on the previous layer. Now the collar is removed and the extra soil will be trimmed off by using spatula. The mass of the mold with the base plate and the compacted soil now is taken, and the bulk density of the soil is determined by using the formula that is I am showing here, that is rho equals to m by v, that is formula number 1. Here rho is the bulk density, m is the mass of the compacted soil, v is the volume of the mold. Now note this, volume of the soil will be 1000 cc. We could find out this volume of the cc by the specification of the mold which I have given in the first slide. Now bulk density, we can find out the bulk density by using this formula m by b that we know. Now after getting the bulk density of the soil, the representative soil sample are taken from the mold to determine the moisture content. We will find out this moisture content by using oven dry method. Now this samples, now this same procedure is repeated with adding 3% more water to the previous soil sample until the bulk density get reduced. Now we will get water content corresponding to each trial from the sample kept in oven, which I have which we will have in the oven to find out the moisture content. Now we'll have the moisture content and the dry density can be found out by using the formula. I am showing you the formula. That is already we know this. The dry density we can find out by using this formula number 2, that is rho suffix t equals to rho divided by 1 plus w. Here rho is the bulk density, which I already find out this bulk density in our previous step, and in w is the water content, which I already know from the oven dry method for the corresponding trials. Now coming to this graph, now what do we have? We have the two things, that is water content and corresponding dry density for the several trial. Now in this graph we have 6 numbers of trial, and for 6 numbers of trial we have the water content and corresponding dry density. Now by using this value, by using this data, we'll plot this graph between water content and dry density, and we'll get this type of curve. Now from this curve, from this peak point of this graph, we'll have the OMC, that is optimum moisture content, and the corresponding maximum dry density. Now this is our desired data which we need to find out from the standard Proctor test, that is optimum moisture content and the dry density of any soil. Now that is the full procedure of this standard Proctor test.